Welcome to This Explainer. Right out of the gate, we're looking at a cyber attack that honestly feels like it was ripped straight out of a high-stakes Hollywood cyber thriller. We're talking about an attack that completely bypassed traditional security, hid in plain sight, and literally turned the builders of our digital world into unwilling accomplices. Today, we are unpacking the incredible rise, the exponential spread, and the ultimate coordinated takedown of the Glassworm botnet. Just picture this. 35,800. That is the number of developer machines instantly compromised in the initial wave of this attack. And these weren't just everyday users, right? These were software engineers, people with high-level access to sensitive corporate networks and source code. But the absolute wildest part of this massive compromise, it was executed by an attack that no human eye could even see. Okay, let's dive into this. Here's how we're going to break it all down today. First, we'll look at the invisible threat. Then we'll map out the unkillable network. After that, we're getting into the zombie payload, followed by the supply chain spread. And finally, we'll wrap up with the coordinated takedown. So, starting with part 1, the invisible threat, hiding right in plain sight. Our story actually kicks off in October 2025. Researchers over at Koi Security's threat hunting team stumbled onto a highly disturbing anomaly. There was this seemingly legitimate, fairly popular developer extension on the OpenVSX marketplace called CodeJoy. Well, an update push to CodeJoy started making some really weird network connections that had absolutely nothing to do with its actual job. But here's the kicker. When researchers looked at the source code to find the malware, they couldn't see a thing. The code looked perfectly fine to the human eye. How? Because the attackers used this mind-bending stealth technique involving Unicode variation selectors. Now, these are special characters built into the standard text encoding systems we use every single day. Their intended job is just to slightly alter how other characters look. But on their own, they produce absolutely zero visual output. So to a human eye or even a basic security scanner, they just look like innocent empty white space. But the attackers weaponize these invisible characters to encode malicious JavaScript. And this brilliantly illustrates the core of the problem right here. Take a look at this comparison. On the left, this is what the developer, or honestly anyone doing a standard code review, actually sees. It's just a few blank lines between normal code. Completely harmless, right? But on the right, this is what the computer's JavaScript interpreter sees. Highly sophisticated, executable, malicious code. This technique completely shattered the traditional security model. You can't spot what you literally cannot see. The malware was entirely transparent, which, you guessed it, is exactly how it earned the name Glassworm. Moving on to part 2. The unkillable network, a literal hydra of command and control. Now, invisible code was really just the first layer of this nightmare. Once Glassworm was actually inside a developer's machine, it needed instructions. It needed a command and control, or C2 infrastructure. So, the attackers engineered this brilliant, multi-layered redundancy system. The architecture they built was essentially a digital hydra. You cut off one head, another instantly takes its place. Step 1, their primary command server was actually the Solana blockchain. They literally encoded their instructions right into the memo fields of public blockchain transactions. And because blockchains are immutable, authorities couldn't just take it down. Step 2, they used Google Calendar event titles as backwrap steadtrops for instructions. Think about it. What corporate firewall is going to block Google Calendar? Step 3 involved dynamic, direct IP connections. And Step 4 utilized the decentralized BitTorrent distributed hash table network. It's just a crazy level of redundancy.
But what's truly staggering here is the sheer economics of the attack. Let's say a defender somehow managed to actually block the specific IP address the blockchain was pointing to. The attacker didn't care at all. They could just post a brand new transaction pointing to a new server. And the cost to rotate this unbreakable Solana C2 infrastructure? 0.000005 Sol. That is literally less than a single penny. They could force cyber defenders into an impossible, never-ending game of whack-a-mole for absolute pocket change.
Let's move to part 3 and see how this builds. The zombie payload, the ghost in the machine. So once Glassworm gets its instructions from that unkillable network, things get so much worse. It downloads its final stage, a module the attackers themselves horrifyingly named the zombie payload. This is where we see exactly what happened to those 35,800 infected developer workstations. Zombie wasn't just some simple data thief. It was a full-spectrum network penetration toolkit. Just look at these capabilities. It deployed SOC's proxy servers, literally turning highly secure developer machines into criminal proxy nodes sitting deep inside corporate firewalls. It utilized WebRTC for direct peer-to-peer control to totally bypass standard network defenses. It used BitTorrent for decentralized command distribution. And definitely the most terrifying part, it installed hidden VNC, or HVNC. And here is exactly why this matters to anyone working in tech. HVNC is remote desktop access, but it is entirely invisible. It operates inside a hidden virtual desktop. It doesn't trigger your task manager, there are no weird pop-up windows suddenly appearing on your monitor. An attacker sitting halfway across the world could be secretly controlling your secure machine, browsing your internal corporate tools with your authenticated sessions, and reading your proprietary source code, all while you're sitting at the exact same keyboard, completely unaware that you've got a digital ghost in the room with you. Which brings us to part 4. The supply chain spread. Exponential infection. As horrifying as that zombie payload is, we have to remember that Glassworm was at its core a worm. It actively sought to replicate. It earned that name by automatically self-propagating through the global developer ecosystem, basically turning a targeted supply chain attack into a massive exponential infection event. Once inside, it aggressively hunted for credentials on infected machines. It stole NPM tokens so it could automatically publish malicious versions of new software packages. It snatched up GitHub credentials, which it then weaponized to poison over 300 different code repositories. It even targeted 49 different cryptocurrency wallets, draining those funds just to finance the whole operation. And because developers use all sorts of different operating systems, Glassworm was built to be cross-platform. It spread its invisible payload across Windows, macOS, and Linux systems alike. Every single new victim just became a launching pad for the next wave of attacks.
Finally, part 5, the coordinated takedown, striking back.
For months, Glassworm absolutely ripped through the open source community. But the cybersecurity world wasn't just sitting by watching it happen. Behind the scenes, a massive, totally unprecedented counteroffensive was being planned out. From its terrifying invisible discovery back in October 2025, defenders watched it spread exponentially into the NPM and GitHub ecosystems throughout early 2026. The tension was just mounting as thousands of developers were silently compromised. All of this was building right up to one critical, decisive moment, May 26, 2026. Now, taking down a digital hydra requires absolute perfection. If defenders took down just one or two of those command channels, the botnet would automatically use its redundancies to quickly reconstitute itself, and they'd be back to square one. So CrowdStrike, Google, and the Shadowserver Foundation formed a massive coalition. And at exactly 1:40 UTC on a Tuesday, they executed a simultaneous strike. They needed flawless precision and timing to hit every single one of those 4 C2 channels, including the Google Calendar dead drops and the traditional servers, at the exact same second. And you know what? It worked. The coordinated strike successfully severed the botnet operators from their infected machines. They completely lost their ability to deliver new malicious payloads. Instead of reaching out to the attacker's infrastructure, all those thousands of Glassworm-infected machines were successfully redirected. They started beaconing to a benign, safe IP address operated by CrowdStrike, 164.92.88.210. The Glassworm was finally, decisively shattered. So the crucial point here is that this entire event highlights a fundamental shift in modern cyber warfare. And I think it's perfectly captured by this quote from CrowdStrike. Adversaries are no longer just targeting products, they're targeting the developers who build them. Think about it. Attackers realize that trying to breach a hardened corporate perimeter is incredibly difficult. But if you can invisibly compromise a developer's workstation, if you can poison the software while it's still actively being built, you bypass that perimeter entirely. The builders of our software have now become the absolute frontline targets. Which leaves us with this final thought to ponder from today's explainer. We rely heavily on open source code and developer tools to build almost everything in our modern digital world. But if the code you write and the everyday tools you use can be weaponized completely invisibly right before your eyes, how safe is your software supply chain really? It's a pretty chilling question, and definitely one that every single organization needs to be asking themselves right now.